Today, we find ourselves in a world where we've heard sounds from the farthest reaches of our solar system. We can listen to the distant sandstorms on other planets and even sense the hunger of meteors from millions of miles away. However, despite our technological advancements, we can only observe various parts of our own planet through satellites. For example, Antarctica's remote regions remain unexplored, and the Amazon jungles hide many secrets. No one dares to venture into the Sahara Desert for extensive research. On one side, we possess considerable power and capabilities, but on the other side, we face a significant energy challenge, particularly in places like Antarctica, the Sahara Desert, and the Amazon jungles. The problem lies in our lack of available energy sources in these areas. Until we can harness energy, even by installing solar panels in Antarctica, we'll remain vulnerable to harsh conditions. The harsh climates of Antarctica and the dense Amazon jungles make it difficult to establish transmission lines or solar systems. So, if we run out of electricity, our options are limited. However, advancements have made it possible to access these remote places, even in deserts with no transmission lines or solar panels. Today, we'll explore how these possibilities have unfolded and what the future holds for humanity in these challenging environments. The inventor Nikola Tesla, who first harnessed electricity, had a brilliant idea. He believed that electricity could be transmitted wirelessly. Otherwise, many people around the world might not have access to this amazing technology, and it would take years or even centuries to reach it. He started working on a way to transmit electricity wirelessly, but unfortunately, lack of investment took the history in a different path, and we ended up with wired electricity. However, the challenges I mentioned earlier, or the idea that Nikola Tesla had about wireless electricity, has been a fascinating topic for scientists and a favorite subject for writers for more than 150 years. The idea of wireless electricity in its initial form emerged in 2014 when Japan's space agency, or the Japan Aerospace Exploration Agency, along with another tech company, successfully transmitted 1.8 kilowatts of electricity over 55 meters without any wires. Japan's experiment was part of a space solar power grid project where they aimed to extend a 400-kilometer-long solar panel wall on the surface of the moon, allowing energy generated in space to be transmitted to a ground station via a laser beam. However, it didn't stop there. Driven by a vision, China thought beyond Japan and realized that the sun, the very heart of the entire solar system, is an immense source of energy. They set out an artificial sun in their lab to create wireless transmission of this energy, and they managed to succeed, pushing the boundaries of what was possible. But space is a place with no day or night, and it has no weather. People on Earth haven't been able to generate electricity in space because the models we have for producing electricity are bulky and weighty. Now, if we want to take the concept of space solar energy seriously, we'll need to send a lot of bulky and heavy solar panels into space. After that, we'll need to organize them, maintain them, and generate electricity from there. All of this is an incredibly costly attempt. The cost of projects like these, making solar energy in space and maintaining it, will be much more expensive than our current energy sources, because the energy production models we had been heavy, bulky, and had to contain a lot of complicated mechanisms. But on January 3rd, 2023 at CalTech University, things changed. They sent lightweight solar panels into orbit using just a simple fabric. These panels not only produced electricity, but also safely transmitted it back to Earth. What's exciting is that we no longer need complex space installations for solar energy. It's as easy as laying out lightweight solar blankets, spreading them out, and letting them work their magic. These blankets will continuously capture solar energy and send it to local grid stations. And when I say grid stations, I mean smaller ones, perhaps on our own rooftops. These smart devices will efficiently harvest solar power and supply it to our homes, powering our everyday lives. Now, with all types of unfiltered light like ultraviolet, X-rays, and glamorous light in space, we can also create electricity. And this electricity will be so abundant that our everyday problems will be solved. In the future, just like the internet will be available all over the Earth through Starlink satellite, electricity will be too. Those big power lines you see along the roads will disappear, and electricity will come to your home through devices like your dish or antenna with very little price, and this electricity will be abundantly available 24/7. We hope you enjoyed our video today. If you like our content, please start the video with a thumbs up, because comments are your way to express your opinions and they help us improve our work. Until next time, take care.